We just spent a lot of time talking about conventional hydroelectric. We're going to start to get a little bit weird with this, right? So, turns out we can use water and kind of naturally occurring, characteristics of water to generate electricity in other ways. Specifically, we can actually generate some electricity using some things that happen in the ocean. The first one we're going to look at is actually what's called tidal energy. It uses what's called either a tidal barrage or a tidal dam. And the way that this works is the force of the moon, right? The gravitational force of the moon kind of sloshes the water on Earth around because water is a fluid. And so as the moon and the Earth are kind of in orbit, the water does some weird things. And so what we see is there's this very long wavelength wave that travels through the oceans. Its wavelength is about 12 hours long, and that's what's called a tidal wave. People misuse the term tidal wave all the time. They mean tsunami when they say tidal wave, but a tidal wave shows up twice a day, every day, right? And it turns out we can take advantage of that. So if we have a very specific geographic condition met, so we have the open ocean here, and then a lake or a river, kind of inland lake or a river, that is ultimately draining to the ocean. We have this in quite a few places, but what happens is as the tidal pulse, or this kind of lump of water, shows up in the open ocean, it's traveling across the open ocean, it will backfill this inland lake or river. It happens in like an estuary environment. And then as that tide passes on, so as low tide starts, that water then empties back out. So every day we've got this inflow and outflow twice a day. And we would put our tidal dam or a tidal barrage essentially in the way of that. And so this is something similar to a hydroelectric dam, although it's a hydroelectric dam that runs in two directions, right? So a typical one that we were talking about on a river, unidirectional flow, water is flowing downhill, all the turbines are built that way. In this case, we have to spin the magnet as the water is both moving in this direction and as the water is moving in that direction. And to do that, we could use something that's not too different than a fan that you might use on a cool day, right? So something that we could kind of set in the way, and as water was passing through either direction, it would still spin. If we think about how this system would work in, really in cross-sectional view, this would be when our tidal pulse of water first shows up. So the elevation of the water of the ocean is higher than in our little bay, and we've kind of restricted the flow with a series of these small pipes or channels that kind of run through there. And so obviously you can see in this situation, the sea level is higher than the bay, and water is going to flow through that little channel. And when it does, we can spin the magnet, right? So again, taking advantage of some technology that we've talked about quite a bit. After that tidal pulse passes on, now we start to get to low tide in the open ocean, and our bay is at higher elevation. And so in this case, water is going to flow back through our tidal dam or our tidal barrage in essentially the opposite direction that it had already done. So the peak tide, right, high tide comes twice a day, which means 2 times a day water's flowing in. Low tide also comes 2 times a day, so 2 times a day water's flowing out. So there's essentially 4 power cycles in one day. So if you have the right kind of geography, putting in something like this is a really interesting way to generate electricity using tides. This particular structure is in France. This is a really interesting example of a tidal barrage. So here it's also a bridge, right? Because you'd have a bridge that spans that kind of narrow spot anyways, right? So here it's a fully functioning bridge, but it's also generating power. We don't necessarily have to put in something like a tidal barrage in this case. We can do it if we have a similar environment where water is flowing in and flowing out. We don't necessarily have to build an infrastructure. We can also put out in the sea floor basically small little isolated fans that are just turning as the water flows through. You can see in this image, these little turbines are what are called tidal fans, right? So it's a fan, again, like the kind you'd use when it's pretty warm out. But if it's an isolated area, they can just move as the water is flowing through. You would also be able to install these in a river, right? So it doesn't necessarily have to be kind of two directions of flow. It can just be one direction of flow, and you don't have to hold the water back, which that's actually going to be, especially in the case of hydroelectric, that's going to be one of our environmental concerns, because as we hold the water back, it turns out we also hold the sediment back, and that can have some repercussions on kind of the environments that animals and fish really need to thrive. Another way to generate electricity from the ocean, in this case it's not using tides, it's actually using wave action. So we always kind of think of waves as moving, kind of passing along, but the water that the wave is passing through doesn't move, right? So if we were to imagine a duck, I don't know if I can draw a duck, I'll give it a try. It's a pretty bad duck, but duck nonetheless, or seabird, undifferentiated seabird. So if our mean sea level is something like this, as these waves are passing, this duck isn't moving with the waves, the duck is actually just moving up and down, right? And so we can take advantage of that up and down movement and use that to pass, a copper coil past a magnet, or kind of run the magnet up and down, and again generate an electrical current. So there are a couple of ways you can do this. You can see here, this is an experiment in Portugal where they have these big kind of arms attached to a jetty. You can see that rocky structure is what we would call a jetty. And they have these big floating platforms, and as the waves are moving up and down, the elbow of that platform is moving, and inside of there are pistons that are pushing back and forth, effectively spinning the magnet. It might not be a traditional spin, but remember, all that really has to happen is the magnetic field is in flux, right? The magnetic field has to be moving, or the copper moving in relation to the magnetic field, and that will generate a current. So this arm kind of moving up and down. There's also an installation of these out in the open ocean, right? So they're not necessarily hooked to a jetty, or we can build a small platform, and off of that platform we have these big arms moving up and down. It's a pretty novel way. It doesn't generate an incredible amount of electricity, but I think, again, one of the things that we start to think about when we're, doing all of this, we keep using the term energy portfolio. So kind of multiple different ways to generate electricity, all kind of collectively can help the overall problem. Personally, my favorite way to generate power from waves is to use these things called sea snakes. And what they are these giant kind of columns or cylinders. They're segmented and they're hooked together in groups of 4 or 5. And as the waves pass through, the snakes kind of wiggle in the waves. And the internal pistons kind of hooked to one, inserted to the other, again, are passing back and forth this magnetic field, or the magnetic field is fluxing over the copper coil. They're anchored to the ground, and they do a pretty reasonable job at generating electricity. You can see here it's kind of a cartoon diagram, but these have definitely been deployed in a real sense. So here's an example. Some of these ones don't look incredibly active. They don't look bent at the moment. But here, again, this one you can see is in action. So this is a company out of Scotland that made these. As with a lot of these companies, I think this particular one is having some problems with infrastructure, and they don't necessarily have the investors. So there's kind of a lot going on here. But the sea snakes are personally my favorite kind of funky and creative way to generate electricity from wave power in the oceans. Here, this is a diagram that kind of has a lot of these things going on. So these are all ways to generate electricity from the ocean. So standard hydroelectric, as we've been talking about, that's putting a dam in a river, spinning the magnet. We've been doing it for a long time. But here, this shows ways to generate power from the ocean, from either the tides or from the wave action. So you can see in the foreground of this image, there are these kind of kites that have a little fan attached. And then there's some tidal fans that you see behind that. So those are a little more solid, like they're not kind of loose on a cable, as we saw in the case of the kites. There's another thing you can see in the background that's yellow. These are basically like, best way to imagine it would be like a container ship. You might buy a storage container, or like you've heard of container houses. But it's basically a buoy. It's filled with air, so as the waves pass, it rocks back and forth and spins the magnet in a sense, right? Kind of inserting and pulling out either a magnetic field or a copper coil. As that's moving back and forth, it's generating electricity. And then in the far background, you can see my personal favorite, the sea snakes, right? A totally cool, novel idea in a way to generate electricity from waves. So mostly we've been talking about like pretty big picture stuff. One of the cool things about spinning the magnet is we can actually generate power on the very small scale. So this is actually currently a Kickstarter project, I believe, called the iStream, and it's a hydroelectric power plant, enough to charge your phone. But you know, if you're out backpacking, or if you have a cabin and you're kind of living off the grid, or something like that, you're out doing field work maybe, you can stick this thing in the stream, and as it spins, you can have it charge. You know, a lot of people use those kind of portable battery packs, right? So you could have it charge up your battery pack when you're off in the day. When you come back from work in the evening, you can plug in your phone or your device and have it charge overnight. So, you know, traditionally, you know, personally, I use some solar stuff to do that. I have a little fold-out kind of photovoltaic package, but it doesn't work on a cloudy day. So if it's a perfect field day, which means it's kind of overcast and not too hot, I'm not going to generate any power. When I get home, or get back to camp, I'm going to be out of luck. Something like this could really solve that problem. All right, so we've talked about a couple of different ways to generate electricity, you know, hydroelectric, and then, you know, tides and waves. So in the next video, we're going to take a look at some of the hydropolitics, kind of who's in, who's out, and then also we'll have a small section where we look at the problems associated with hydroelectricity. All right, see you in the next video.